So we're starting our final topic on energy and sustainability. Now, for the most part, this topic is really an application of all the mathematics that we've learned so far. So there's not really any particularly new skills that we're developing here. There may be a couple of different types of concepts, but it's really just looking at how we apply mathematics in terms of like rates, ratios, formulas to real life situations. The first thing we're looking at is heart rates. So we measure heart rate in beats per minute. So in PE, you may have practiced taking your pulse, so counting how many times your heart beats in a minute, okay, or in 2 minutes, and then converting it into a simplified rate. So heart rate beats per minute, and when you measure the heart rate, it can be used to examine a person's health, particularly if you're looking at during exercise. So what you might do is you might measure your heart rate before you start exercise, then your heart rate after exercise, but also measuring how long it takes for you to return back to your normal heart rate. So these things are really important when determining how healthy someone is or their fitness level and things like that. When we talk about a person's maximum heart rate, it's the upper limit of what your body's able to handle. So anything larger than that, your body will struggle to sustain itself. So the maximum heart rate is given as a formula. Now you don't need to memorize these formulas. These will always be given to you if you're required to use them. So for males, it's 220 minus their age in years. Okay, so if they're 10, then you minus 10. If you're 35, you're going to take off 35. For females, it's 226 minus their age. So that's just a way that we can calculate it. So here's a couple of examples. Ryan took his pulse and counted 117 beats in 1 minute and 30 seconds. Okay, so make sure you look at that whole number. Find his heart rate in beats per minute. Okay, so that's always the unit we're using. So we have 117 beats, and then the time was 1 minute and 30 seconds. We need to convert that into a decimal. So 30 seconds is half a minute, so that's actually 1.5 minutes. In order to work out beats per minute, we want to work out for 1 minute. So we're going to divide by 1.5 on the right. So whatever we do on the right, we also do on the left. So that's what it means to find a rate. So when we divide by 1.5, we end up with 78. So it's 78 beats per minute. In example 2, Edith is 18 years old. What is her maximum heart rate? So let's have a look up here. Edith is a girl, so we're looking at females. Her heart rate is 226 minus whatever her age is. The maximum heart rate, just use this abbreviation MHR here, okay? Maximum heart rate is 226 minus 18, which is 208. So Edith's maximum heart rate is 208 beats per minute, which is very, very fast. Part B, recommended daily exercise is between 55% and 85% of the maximum heart rate for 20 to 30 minutes. In what range should her heart rate be when she's exercising? So that's sort of another guide as to what's considered actual exercise and what's actually going to benefit your body. So if we look at the minimum, okay, the smallest amount her heart rate will be using the 55%, and the largest value would be the 85%. So in part A, we've already worked out her maximum heart rate. So the minimum range for her heart rate for exercising should be 55% of that, which comes out to be 114.4, and the maximum is going to be 85% of that, which is 176.8. So that means, we'll just round this off to the nearest whole number, her heart rate needs to be between 114 and 177 beats per minute in order for her to be doing something beneficial with her exercising. So that's one way that we can look at how we can use the heart rate. So we know that if if her heart rate has increased to approximately that, she's doing some good exercise there. Another way we can work out good exercise is looking at a target heart rate. And this is probably what a lot of exercise people, people who do sports sciences and helping athletes to achieve their potential, this is probably a calculation that they use a fair bit of. Probably a little bit more sophisticated than what we're going to do. So the target heart rate, or we can also call it training heart rate, is the heart rate at which you would benefit from the exercise. Now, this does depend on a person's age, their gender, their actual physical fitness. So there's no one way of calculating this target heart rate. So the target heart rate for you may be different to the person who's sitting next to you. And you probably want to see a specialist in order to work this out, particularly if you're trying to train for quite high levels of competitive sports and things like this. We also talk about an exercise intensity, so it's just talking about how intense that exercise is. So is it something that's going to push your body a lot? Is it something that's like not so strenuous on your body? So we have low intensity, moderate, and high intensity. Again, these are just averages, they're just approximations. If you really wanted to look into these sorts of things, there's a lot more sophisticated ways of calculating this. So if we're looking at low intensity, we're looking at maybe going for a walk or just an easy sort of bike ride. Moderate intensity would be if it was a little bit more brisk, so you're sort of like doing a bit more of an actual walk, walking uphill, or a strenuous yoga session, apparently. And then high intensity would be things like circuit training, weight training, sprints in the pool, going for like long runs, things like that. So, and a formula that's been given in your textbook is to work out the target heart rate. The target heart rate is the intensity times the maximum heart rate minus a resting heart rate, then adding the resting heart rate. So resting heart rate is just when you're not doing exercise, just normally, what is your heart rate then? So this is a formula that we can use, and we're just going to take the information that we've got and apply it to this situation. So Sean is 38 years old and goes for a brisk walk in the afternoon. His resting heart rate is 85 beats per minute. Find the range for his target heart rate for this moderate intensity activity. So again, these numbers, this formula, they're all going to be given to you if they want you to use them. So if we're looking at a brisk walk, we're looking at 50 to 70% for your intensity. Okay, so the exercise intensity is going to be 50 to 70. So 50 would be the lower end, 70 would be the upper end. So the first thing we need to do before we do anything else is calculate his maximum heart rate. So going back to the top, you might remember Sean's a guy, so his maximum heart rate is going to be 220 minus 38, which is 182. So if we're looking at a range, then the minimum intensity was 50%, the maximum intensity was 70%. So these are the values that we're going to apply. So the target heart rate is 50% times maximum heart rate minus resting heart rate plus the resting heart rate. And so when we calculate that, we get 132.5. If we work out the maximum, so using the intensity of 70%, 70% times 182 minus 85 plus that resting heart rate back on. And that comes out to be 151.5. So just doing a normal rounding there, his target heart rate would be somewhere between 132 and 153 beats per minute. One extra thing that isn't actually in your textbook, this actually appears in the Standard 1 textbook, so I think it's worth talking about as well. And it's talking about blood pressure. So it's another way of measuring health for, I think for more older people. Every time they go to the doctor will actually measure their blood pressure, okay? Ideal blood pressure does vary from person to person. and it is measured using two numbers. So if you have a look at the picture on the right, that's sort of how a lot of doctors measure blood pressure. There are automated machines that do that now. Like you can buy one, keep it at home, you can measure your blood pressure at any time, things like that. But it is a really important thing to be looking at. So blood pressure is measured using two numbers, the systolic blood pressure, and that's usually the bigger number, and it shows the pressure in the arteries as the heart pumps out blood. The diastolic blood pressure is the lower number, and usually the second one, and it indicates the pressure as the heart relaxes before it goes and beats the next time. The units for blood pressure are called millimeters of mercury. Okay, so it's written as mmHg. For you chemists, Hg is the chemical symbol for mercury, so mmHg. So that's just how it's measured. The problem with blood pressure is if you've got very high blood pressure, it can lead to a lot of health problems. So that's why for a lot of older people, a doctor will always take blood pressure as part of a medical routine. Okay, so with all of this, you don't need to know a lot about it. Most of it is just about how you can apply this sort of information to things that there are, like to given information. Okay, so you don't need to know perfectly what systolic and diastolic blood pressure is, but a question may have systolic blood pressure means this, diastolic blood pressure means this. This is what we're trying to work out. Can you do it? Okay, so an example would be like question 4. So classify the health or possible problems of the blood pressure of the following people. So you can see a graph on the right hand side. So we've got diastolic blood pressure along the bottom, systolic blood pressure along the side. So for certain values, we want to look at the combination between systolic and diastolic blood pressure in order to look at whether their blood pressure is too high, is it too low, or is it around a normal range. So if we look at the first one, Fred, his blood pressure, systolic number is 132, diastolic is 95. So what we want to do is we want to find approximately where his blood pressure lies on the diagram, so then we can sort of say whether it's normal or whether he's sort of heading towards the high blood pressure. So we're going along systolic first. So if we want 132, 132 is about there. And then the diastolic is 95, 95 is here. So his blood pressure puts him right there. So we can look at that and say he's got high blood pressure, probably at stage 1 hypertension. Okay, if we look at the next person, we're looking at Molly. Let's use a different color. Molly's blood pressure is 100/60. So usually blood pressure is given as with a slash on it. So the first number is your systolic, second number is diastolic. So 100 would be approximately here. 60 is going to be here. So Molly is going to be about there. So we can see Molly's blood pressure is pretty normal. The last person we've got is Jordan. So Jordan is 110/85. So 110 is going to be about there. 85 is about here. So Jordan's going to be approximately there. So Jordan's probably got pre-hypertension, so it's not in a very serious stage yet, but it's a little bit higher than normal. Okay, so Jordan's probably at a stage of pre-hypertension. Of course, all of this also depends on how what happens when you go to your doctor, because sometimes when you're older, you tend to have higher blood pressure, and a higher blood pressure could be normal as well. So at any of these points, you should really be consulting your doctor about any of these numbers that you're getting. In your textbook, they don't have much they won't have anything about blood pressure. So just focus more on the heart rate and doing your rates calculations. If you want to have a look at a blood pressure question, if you go into the past HSCs, the standard 1 paper actually had a blood pressure question in there. So you can go and have a look at that if you want to.